So an equation is a relationship between algebraic terms that are true only for a certain set of values. And for example, if I write this equation 3x minus 5 is 10, this is only true for a specific set of values. In this case, there's only one value for x as a number that would make this true, and we can actually solve for what x would be. We add 5 to both sides, this becomes 15, and x is 15 divided by 3, which is 5. So only if you replace x with 5 would this equation or this relationship would hold true. So that's the meaning of equation. The most common types, I'm just going to list the common ones that appear on the GRE. The first one is the linear equation. It's called linear equation in one variable, and that's the example that I just used. A variable referring to the unknown. So 5x minus 3 equal to 7. And linear means there's just one power of x. So it's x to the 1 or just x. It could also be a linear equation in two variables, meaning two unknowns, two algebraic unknowns. And this could look like 3x plus 5y equal to 8. And there are also some nonlinear equations that do appear on the GRE, and these are in two variables. And it's not that they actually want you to solve these, but they may ask you to rearrange these relationships. So that's an example. It's nonlinear, and there are two unknowns, x and y. The other examples are the ones that show up are quadratic equations, a common one. So quadratic equations in one variable or one unknown. An example would be 2x squared plus 5x minus 12. And this has two solutions. There are two values of x that make this equation true. Another variation, it's a little less common, is the quadratic equation in two variables. And we'll go over these a little bit later, but an example could be something like that, where it has a quadratic form because you have the second power, and there are two unknowns, the x and the y. So those are just the list of common types of equations. Now, when it comes to solving equations, there are some specific type of equations they expect you to solve. And what that means is, by solving means to find the value of the unknown. The example that we did earlier, finding the value of the unknown that makes the equation true. So, one example could be 3x minus 9 is 12, and the question is, what is x? Now, the operations that are acceptable are you can always add the same term to both sides. And the reason for that is if you have an equation, say 8 plus 7 is equal to 15, we can add 2 to both sides. The relationship still holds true. I can subtract 7 from both sides. And the two sides are still equal because I am taking out the same amount. So you can add or subtract the same term from both sides of the equation. You can also multiply and divide by the same number. And you just have to make sure when you're multiplying and dividing that it has to be non-zero, because division by 0 is not defined. So again, if I doubled both sides, it still holds true, because really it's just 15 is equal to 15. So if I double it, 30 would still be equal to 30. So all these operations preserve the original relationship, and you have to rely on these operations to solve for an unknown, like here, x. And the way you would do this is that if you have 3x minus 9 is 12, we can add 9 to both sides. And the reason for that is we're trying to isolate the unknown. This becomes 0. So we get 3x is equal to 21. And to isolate x, we divide both sides by 3. This becomes just x. And 21 over 3 is 7. So the solution is x equal to 7. Of course, the GRE, they're not going to have examples like this. This is too easy. I would say a more typical example would look like, given 6 minus x minus minus x is equal to minus 2 times 3 minus x. And the question is, solve for x. So something like this would be more typical, where there's a lot of confusion with these negative signs. So it becomes 6 minus x minus of minus x is plus x. And here we're going to distribute this minus 2 over the two terms. It becomes minus 6 minus 2 times 3. And then minus 2 times minus x would be plus 2x. And here the two x's drop out, and I get 6 is equal to minus 6 plus 2x. I'm going to add 6 to both sides. This side becomes 12. That disappears, and I should write that just to maintain equality, and that's equal to 2x. And I divide both sides by 2. I get x equal to 6. So the solution to that equation is that x is equal to 6. So again, these operations of addition, subtraction, division are always acceptable. Now some equations, even though they might seem like you might be able to solve them, they could be an identity, meaning it holds true for all values. For example, if you're given something like this, if you expand that side, this becomes 6 minus 3x. They are just identical, which means that this original relationship holds true for all values of x. So no matter what you select for x, this relationship holds true. So that's an example of a simple identity. Now, we're going to next cover what are called the simultaneous linear system of equations. And an example of that would be 3x minus 2y is equal to 13, and x plus y equal to 1. So the linear referring to, again, just x and y, and system referring to these two equations. And we're looking for those pairs of x and y that satisfy these two equations. So in general, there's only one unique pair. There are some cases where you could have multiple, but most commonly there would be a unique pair. And those are the only ones we're looking at right now. And there are two methods to solve these. One is called elimination, and you can choose to do it either way. And this is the approach here is to combine the two equations. Somehow you might have to either multiply, divide one of these two equations, but you're combining these two equations by either addition or subtraction. Now, when you have two equations, you can always add or subtract the two equations, and the reason for that is that if you have, for example, 8, let's actually 3 plus 5 is 8, and 2 plus 1 equal to 3. If we add these up, 3 plus 2 plus 5, so we're adding each of these terms, you'll see that this still holds true. 5, and this is 6, and that's 11. So you can always add two equations because these quantities are equal, so you're adding the numbers to each other. You can also subtract. 2 plus 1, so you're subtracting each term individually. So this is 1, this is 4, 8 minus 3 is 5, still holds true. So you can always add or subtract. Now if you go back to our system of equation that we're using as an example, I want to combine this somehow so that I can get to an equation that has only one unknown. Now if we just add these two equations, we get 4x minus y equal to 14. Now that doesn't really help us. We get an equation which has two unknowns. So we need to add or subtract in a way that one of the unknowns is eliminated. And you have to observe the equation to see what's an appropriate step. So here we see minus 2y and a plus y. So if I could double or make this somehow 2y and then add them, I know that the y terms would disappear. So if we keep the top term the way it is, I'm going to multiply the bottom term by 2. And we can do that because I'm multiplying each term. And so the relationship still holds true. So I get 2x plus 2y equal to 2. Now when I add these two, these terms disappear. And what I'm going to get is 5x is equal to 15. And x is equal to 3. And then to solve for y, I can either just substitute it back in this equation, So that would be x is 3, so y would be minus 2. So this is sort of the elimination approach. Now, we could also do other ways. We could, if we chose to, let's say, solve for y directly. So our choice earlier was to actually solve for x. It was easy to eliminate y, but let's say the question was asking for what is y. In that case, it might pay to directly solve for y, which means get rid of the x term. So I'm going to try to match these two. So multiply the bottom one by 3. So that becomes 3x plus 3y equal to 3. The top one, I'm just going to stack it. And then the key is, can I eliminate the x terms? Yes, if we subtract them. So this term becomes 0, 3y minus 2y, and then 3 minus 13. So here we're going to get 5y equal to minus 10, and we again indeed do get y equal to minus 2. So you can combine them either way depending on what the interest is. The second approach is called solving by substitution. And the system we were using is 3x minus 2y equal to 13, x plus y equal to 1. And what you do is, the approach is to express one variable, and it could be either one, x or y, in terms of the other. And so use one of the equations to express one variable, meaning you could use either one or that to express one variable in terms of the other, and then substitute it in the other equation. So that way you end up with an equation with just one unknown. So here, for example, I could choose to write x is equal to 1 minus y. So I'm isolating x. Then I'm going to take this expression for x and replace it in the first equation. So I'm replacing x with 1 minus y. And now I have an equation with just one unknown, and I can solve this for y. I do the expansion here, 3 times 1 minus 3y minus 2y equal to 13. Subtract 3 from both sides. This side becomes 10, and that consolidates to minus 5y. Divide by minus 5, and I get y equal to minus 2, as we obtained earlier. So that's the substitution approach, and we could have chosen to write y is equal to 1 minus x and substitute that instead. So either choice, you can take either choice. Now, what is important is to choose the right equation, meaning here, if I had said, well, let's use the first equation and write x in terms of y, you would see kind of end up with this algebraic fraction, which is a little bit of a pain to plug in the second one. So always choose the one that's easier. You do have to sort of inspect and look at these equations. Okay, so the next concept is you might be given these system of simultaneous equations, but often the system of equations may not need to be solved. And when I say may not need to be solved, I mean you don't have to necessarily find what the value of x or y is, because it depends on the question. They might be asking you for some combination of the terms. And let me illustrate that with an example. So let's say you're given, so this is a quantitative comparison. You're given this set of equation, and you have quantity A, which is x minus y, and quantity B is 3. So if you look at this problem, we're really interested in x minus y. We don't care what x is, what y is. So in these types of problems, this should serve as a clue that you don't necessarily need to find an x or y. So my experience is that on the GRE, if you see a combination of expression that has a bunch of variables in it, try to create that expression as opposed to solving for x and y individually and then finding their difference. And the most common operations on the GRE are either addition or subtraction. So you should always look for those operations and see if you can get to x minus y. So if you look at these system equations, if I subtract them, I get 2x minus x, then minus y plus 2y, because I'm going to do minus y minus 2y equal to 3. This becomes x, and that term becomes x plus y. And so I get x plus y equal to to 3. So the next concept is that often the system of equations may not need to be solved to answer the question. And I'll present an example that clarifies what I mean by that. So for example, let's say we look at this quantitative comparison. You're given 2x minus y equal to 7 and x minus 2y equal to 4. And then quantity A is x plus y and quantity B is 3. So what I mean by not having to solve for x and y is if you see that in this question we're really just interested in finding the value of x plus y. Don't really care what x is or y is. In those situations when you see a combination of those variables, try to create this expression using the equations as opposed to actually solving for x or y. And the most common operations the test writers expect you to do is either subtraction or addition. So always start there. In some maybe harder problems, you might have to either double one of the equations and subtract, or something maybe a little bit more complicated. But I would say most of them really tend to use those common operations. So here, for example, if I subtract them, so you get 2x minus x is x, and then minus y minus 2y is actually going to be plus y, and 7 minus 4 is 3. So here, without having to solve for x and y, we directly get a value for x plus y, which is 3. So here the two quantities are equal, and the answer is C. So look for this type of a manipulation. The next concept is when you see a question like, what is x in terms of y? So this type of phrase is pretty common, and this basically means solving for one variable in terms of the other. And all that means is that that you express or you isolate one of the unknowns, would be x, and then on the other side you get an expression that has terms with y in it. So a simple example of that would be if you're given, say, x minus y is 3, and the question is, what is x in terms of y? And here we just isolate x, and we get x is equal to y plus 3. So this expression represents x in terms of y. Now if they asked you what is y in terms of x, that means you isolate y. So we have to take this equation, I add y to both sides, it becomes x is equal to y plus 3, and then I subtract 3 from both sides, I get y equal to x minus 3. So this is y in terms of x. So this language throws off a lot of students, so I thought I'd give you this simple example to clarify that. An example of how this could be tested on the exam is you're given this statement, y is 4 less than twice the value of x, and question is, what is x in terms of y? So the translation of this would be y is 4 less than twice the value of x is 2x minus 4. So it's not 4 minus 2x, because we're subtracting 4 from twice the value of x. So that's the relationship, and they're asking what is x in terms of y. And the answer choices will all have y terms in it. So that's also your clue that you need to isolate x or have x alone on one side. So in this case, we would add 4 to both sides. It becomes 2x is equal to y plus 4, and then x becomes y plus 4 over 2. The other common temptation for this type of a problem is, that I've seen a lot of students do, you can't strike the 2 into the 4 and end up with 2. Because anytime you have a plus or a minus, you can't do that. So this is not equal to y plus 2. So that's a common temptation. What you can do is to use this rule that if you have a plus b over c, you can divide each term by c, or in this case, divide each term by 2. So you can write it as y over 2 plus 4 over 2, or which simplifies to y over 2 plus 2. So in the exam, it's possible that's how they might write the answer, or they might leave it like that. So you may have to look at the answer choices as well to see what final form they want you to write the answer. So here's another example of that similar type of a question. You're given 3 times a minus b is equal to 2a minus b, and the question is then what is b in terms of a? So again, they're asking you to express b solely in terms of a. So in general approach is take that equation and do the expansion, so multiply by 3, and then you combine like terms. So that's in general should be your strategy, combine like terms. So a with a terms and b terms with b. So I'm going to add 3b to both sides. This becomes 3a, and then 2a minus b plus 3b, and that becomes 2b. And then I'm going to subtract 2a from both sides. As you become more proficient with this, you don't have to actually be writing these steps. You could just do the steps directly. So I get a is equal to 2b. The question is, what is b in terms of a? So I need to isolate b. So b is equal to a over 2. So that's b in terms of a. The other type of problems you might encounter are what they're called unsolvable equations. And by unsolvable equations, what I mean is that some equations can't be solved, meaning there might be some unknowns in the problem, but depending on how the question is phrased, but you may still be able to answer the question. And so the key is really to pay attention to the question. And I'll give you a simple example. So, for example, if you're given a is b plus 3, and the question is, what is the value of 3a minus 3b? Now, if you notice that this relationship, there's lots of different numbers that satisfy this relationship. And the question is, we can't really find a or b as a unique value, but here they're really not asking for a value of a or b, they're asking for the value of that expression. And we notice here, if we can factor a 3, it becomes 3 times a minus b. And here, if I subtract b from both sides, I get a minus b is 3, which means this piece is 3. So this expression is 3 times 3, or 9. So that's sort of what I meant by saying unsolvable equation. We can't really find a or b, but we can compute this. Now, you can certainly use numbers here as well. You can say b is 2, then a is 5, and use these numbers to compute that expression. And you would find 15 minus 6 is 9. So that approach is fine as well. You may just have to use another example to make sure that it is always unique in case it's a comparison problem or some other scenario. So here's a little bit closer to what might be on the exam. You're given that x minus y is 4, again a quantitative comparison, and quantity A is 3x over 2 minus 2y, and quantity B is 5 minus y over 2. Now again, here we have several approaches. We could either add the y over 2 to both of these terms. So now, because it's comparison, I can add the same number to both sides, because it does change these numbers, but their relative relationship, meaning which one is greater or whether they're equal, remains the same. So if I take that approach, I have just a number here. I can consolidate the y terms, and this is minus 2y really is minus 4 over 2y plus y over 2. Now I can add the numerators. This becomes minus 3y over 2. And if I factor 3 over 2, I get x minus y. Now x minus y is given to us as 4. So this becomes 6. So quantity A is 6, whereas B is 5. So here the correct answer is A. So that's one approach. The other approach you could take here is to substitute. So we have quantity A was 3x over 2 minus 2y, and quantity B is 5 minus y over 2. And what we're going to do is to take this and we're going to write x is equal to 4 plus y, and we can replace x here. So that becomes 3 over 2, 4 plus y. So really just writing this side completely in terms of y, because this side already has just y terms. So I multiply 3 over 2, both of them, 3 over 2 times 4 plus 3 over 2y, and then I'm going to match here the denominator, and then this becomes 6, and I have 6 minus y over 2. So 6 minus y over 2 or 5 minus y over 2. Quantity A is bigger. So again, the answer is A. You can also use numbers. Let's say everything, you just are not able to do any of this manipulation. You just pick two numbers that satisfy this relationship. So it could be x could be 8, y could be 4, and that does satisfy this. Then compute this expression and this expression. So quantity B here would be 5 minus 4 over 2. That's a 2, so quantity B is 3. Then we compute quantity A. X is 8. So that's 12 minus 8 is 6. And let me just make sure these numbers seemed a little bit different than what I had here. So that's 3 times 8 over 2. So 12 minus 2 times 4. Yeah, so it's 12 minus 8 actually. So my mistake here, it's not 6, so that would be 4. So the key thing is quantity A is bigger. So, I mean, that sort of is the downside of using numbers. If you make some careless mistakes like I made here, then you could get a different answer. And the other problem is that because you're using numbers, just one example is not enough. Maybe if you used a different example, the answer changes. That does happen. So you would have to, just one example is not going to suffice. You would have to use at least two. So I would recommend in this problem to use another example. But of course, the most efficient way is to attempt it directly. That's faster, but it's also harder to implement. Now on to quadratic equations. And these are equations that have x to the power of 2. So something simple would be x squared equal to 16. This is one of the favorites on the GRE. So always think of the solutions are x equal to 4 or x equal to minus 4. This is the part that a lot of students forget when they're looking at problems. They only think of x as 4. So remember the negative solution always. And some other variations of this type of equation would be x plus 2 squared is 9. Here, don't do the expansion of that. And I'll kind of, because that's not necessary. Instead, think of that x plus 2 is either 3, meaning this entire thing, or x plus 2 is minus 3, because that number inside is either 3 or minus 3. And now it's a lot easier. Subtract 2 from both sides. One solution is 1, and the other one, subtract 2, is minus 5. So the solutions are 1 and minus 5. Again, the temptation is to think the solutions are 1 and minus 1. No. That's only in the case of this type of a form. So keep that in mind. Now, the standard quadratics, how to solve them. So this is an example of a common one. And if the coefficient of x squared is 1, these are sort of the easiest quadratics, I would say. And they can be solved by factoring using trial and error. And the way you do that is you put x and x, because that's the first term that would give you x squared. Then you put numbers here that would give you 6 with the sign. So we need a negative 6. So either we could have 3 and 2 or 6 and 1. So you look at all the factors of 6. And then you have to put a sign here. And the way you decide the sign is that whatever sign you put on these places, when you add them, it becomes the coefficient of x. So here it's minus 1. No number means it's minus 1. So we have to place either a plus here and a minus here, a minus or plus, because we need a minus 6. So if I put a plus and a minus here, that would give me plus 1. That doesn't work. So I have to actually put a minus here and a plus. And the 6 and 1 is not going to work even with the minus plus or plus minus, because I'm going to get 5x or minus 5x. So the solution is x minus 3 times x plus 2 equal to 0. And that does indeed come out to be the original expression if you do the expansion. That's another way to check. So that would be x squared plus 2x, and then we're going to get minus 3x, and then minus 6 equal to 0, which is really where we started. Now, how do we actually solve? So what does it mean when we say solving quadratic equations? So the concept that we're going to be using is that when you're given that the product of two numbers is 0, then that means either A is 0 or B is 0, or they're both 0. So you can think of this expression as product of two numbers. So x plus 3 is ultimately a number, and sorry, that's actually x minus 3. X minus 3 and x plus 2, each one is a number, this whole thing. And their product is 0, which means that would be the case if this piece is 0, and x minus 3 would be 0 if x is 3, and this piece would be 0 if x is minus 2. These numbers, 3 and minus 2, are called the roots. So let me reiterate this point. It's a terminology that throws off a lot of people. So if you're given this quadratic and you factor it to this, the roots are, you equate these to 0, or you can think of the opposite sign. So think of numbers that make this equation equal to 0. And you can also think of that if you replace x with that number in that equation, that this relationship would hold true. So that's also what we initially talked about as a solution to an equation. So if x is minus 2, we can check, is that equal to 0? So minus 2 squared is 4. Minus 2 is plus 2 minus 6. 6 minus 6 is indeed 0. So x equal to minus 2 is a solution or a root. And then let's check x equal to 3. 3 squared minus 3 minus 6, is that equal to 0? 9 minus 3 minus 6, which is indeed 0. So x equal to 3 is also a root. So that's what this terminology of roots means. So slightly difficult problem could be that you're given this quadratic x squared minus kx plus 6 equal to 0, and you're given that one root is 2, and the question is, what is the other root of this equation? So we know that if 2 is one of the roots, it has to satisfy this, which means if I replace x with 2, then this relationship has to hold true, which is 4 minus 2k plus 6 equal to 0. 4 plus 6 is 10. I move the minus 2k. I just simply move it, but it's really the same as if you were to add 2k to both sides, then divide by 2, k is equal to 5. So now we have our original equation. We can factor this, and again here we have a 6, 2, and 3, and then I need to get a minus 5, so I'm going to have to put the same sign, because when you add these two with the sign, you need to end up with minus 5. And that's the quadratic equation factored, and the roots are 2, 2, and 3. And so here the other root is 3 that we're looking for. So that sort of is the way to utilize this information if you're given one of the roots. Now, a little bit harder quadratics are the ones that have a coefficient in front of x squared. These are much harder to solve by trial and error. Not that it can't be done, but I think there's a simpler way, systematic way of doing it. You may not be familiar with it that well, but I do want to illustrate that. So what you do is you look at the numbers in front of x squared and the minus 12, and you multiply those two, you get minus 24. Then you have to find two numbers that multiply to give you minus 24, and they add up to give you the coefficient of x, whether it's positive or negative. So we need plus 5. And typically on the GRE, they're going to give you nice numbers so that when you factor, that the factors are easy. So 24, you can think 8 and 3, 12 and 2, 6 and 4, and then you say which numbers I could somehow add that I would get 5, and you notice the 8 and 3. Then you have to decide how to put the sign. You do plus 8 and a minus 3, because you need a plus 5. Then once you have those two numbers, you just rewrite the middle number using those terms. So all we've done is we've rewritten 5x as 8x minus 3x. Once you have this step, you take the first two terms and you factor the largest common term, which is 2x here. We end up with x plus 4, and then you factor whatever's common here. It's minus 3. You get x plus 4. And now we're multiplying 2x with x plus 4 and minus 3 with x plus 4. So this is no different than a times b minus c times b, where b is referring to this entire term. And if you pull out a b, it's a minus c. So here we're going to factor an x plus 4, and we end up with 2x minus 3. And so now this is being factored. And so the roots would be when this is 0, which would be minus 4, or this piece is 0, which would be true when 2x is 3 or x is equal to 3 over 2. So here the two roots are minus 4 and 3 over 2. So this concludes this section of the algebra lecture.